So good morning, everyone, and welcome to Q&I summer course. So students, let me first introduce myself. I am Sunit Kumar, your mathematics teacher. And so we were doing the first chapter, number systems. And in the last class, we had done rationalization. In today's class, we'll do exponents and we'll first learn the properties of exponents. And then we'll do questions based on that. Good morning, everyone. So let's start. So students, as I said, today we'll be doing number system. So this is the 10th lecture for this particular chapter. And prerequisites for today's class is that we should understand operations on real numbers. And second, we should understand exponents and powers. What are exponents and what are powers, which you have already studied in your previous grade, that is grade 8. And in today's lecture, we are going to cover laws of exponents for real numbers, right? So in the previous grade, what we did was all our exponents were integers, right? So we did not come across a rational number in exponent, right? So today in this today's class, or in class 9th, what extra we are going to do is that we'll also talk about these rational numbers on you know as exponents in the questions. So let us first understand the basic concepts of exponents. So we'll revise something what we have already done in the previous grade. The formulas remains the same. So here, let a is greater than 0, okay, be a real number. So let a be a real number, which is a positive real number, and let m and n be integers such that m and n have no common factors other than 1, and n is greater than 0, so n is positive. So in that case, a raised to the power m by n can be written as nth root of a raised to the power m. So basically, a raised to the power 1 by n is nothing but nth root of a. So this is the representation. So in power terms, we write it as a raised to the power 1 by n, and in surd terms, this is nth root of a. Okay. So now a m by n would be, so if I have to write this, what I'll write it as a raised to the power 1 by n raised to the power m. So in this case, a raised to the power 1 by n is nothing but nth root of a, and this raised to the power m. So this a raised to the power m can also be brought inside the bracket, and it can be written as nth root of a raised to the power m. So this is what is being mentioned. So these are the three different ways of representing the same thing, a raised to the power m by n. Is it clear to everyone? Can you please specify your name also? Someone else? Yeah. So, we'll come to the questions when we are practicing the questions, after the class. So at 12:30, we'll see these questions. So right now, let us do the portion which we have to cover. So let me teach this concept first, and then I'll come to the questions also. Okay. Yeah. So let a is greater than 0 be a real number and p and q be rational numbers. Then a raised to the power p into a raised to the power q is a raised to the power p plus q, right? And similarly, a raised to the power p raised to the power q will be a raised to the power p into q. So power of power, you will multiply the powers together. So a to the power p raised to the power q. So here you are taking the power of power. So that is p times q. You multiply these two. And here when the base is same and you are multiplying these two numbers with the same base having different exponents, you add the exponents. Similarly, in the third case, when you divide two exponents having the same base, you subtract the exponents a to the power p minus q. And in the fourth one, if you can see, if the exponent is same and the bases are different, you can take the exponent common outside the bracket. So a to the power p into b to the power p is ab raised to the power p. Similarly, last one, a to the power minus p. So if you have a negative power over a base, that is equal to 1 by a to the power plus p. So negative powers, when they are brought to the denominator, they become positive. So you have to change. If the negative power is a numerator, you will bring it to the denominator, it will become positive. Or if the negative power is in the denominator, you take it to the numerator, it will become positive. Is it clear? Are all these formulas clear to everyone? These are the ones which you have already done in your previous grade. We are just revising it. Okay. So quickly, students, note these down so that you have these law of exponents clear in your mind, and you have that in your notes as well. So when you practice, you can refer to these formulas when it is required. So this is your first, and then 5 more. So total 6 formulas are there which you can note it down. Has everyone noted this down? Okay. Let's go to the questions now. So let us do few examples first. So you can see this first question, 2 raised to the power 2 by 3 into 2 raised to the power 1 by 3. So here you can see that base is same, right? So we did a formula here, a raised to the power m into a raised to the power n is equal to a to the power m plus n, right? So here if you see, if the bases are same and the exponents are different, and you are multiplying these two exponents together, these two numbers together, then you will have the base as same a and the exponents will add. So here in this first case, students, you have 2 to the power 2 by 3 into 2 to the power 1 by 3. So you will add the exponents here because the base is same. So 2 to the power 2 by 3 plus 1 by 3, which is equal to 2 to the powers 3 by 3 or 2 to the power 1, right? This 3 and 3 gets cancelled, which is equal to 2. Is it clear to everyone? Have you understood the concept? So the property which we are using, the identity which we are using is a to the power m into a to the power n is equal to a to the power m plus n. This is the formula which we are using. So you just need to note down here is that if the bases are same and the exponents are different, and you are multiplying these two exponents numbers together, then in that case the base remains same and in the power you add the exponents. Is it clear? Now, can someone quickly tell me which formula are we going to use here? 3 raised to the power 1 by 5 to the power 4. You have to tell me the formula here. Which
Sir,
formula are we going to?
the
Yes.
formula will be x to the power a bracket के बाहर b.
Yeah. So the identity which we are, formula which we are using is a to the power m raised to the power n, right? Power of power. So this is a to the power m into n, right? The power gets multiplied. So here in this case, 3 raised to the power 1 by 5 raised to the power 4 will be 3 raised to the power 1 by 5 into 4, which is equal to 3 raised to the power 4 by 5. Is it clear? Yes, Anna, it will get multiplied. Yes, correct. The powers will get multiplied here, right? Because what we are taking, the power of power. So we already have an exponent term inside the bracket, and then we are taking another exponent outside the bracket. So when such case is there, you multiply the exponents together. Okay, as it is shown here in this formula. Is it clear to everyone? If you have understood, please raise your hand or give me a thumbs up or write it in the chat. Okay. Shall we move to the next now? I hope everyone has noted this down. Okay. Let's move to the next example, students. So this third example is 7 raised to the power 1 by 5 divided by 7 raised to the power 1 by 3. So what formula are we going to use here? Division formula, right? So in division formula, what we do? The powers get subtracted. When the base is same, the powers get subtracted. So a to the power m divided by a to the power n, the base being the same, and when you are dividing two exponents, so this will be a to the power m minus n. Is it clear? So using this, we have 7 to the power 1 by 5 divided by 7 to the power 1 by 3. So this will be 7 to the power 1 by 5 minus 1 by 3. That is 7 to the power, you will take LCM here, right? So LCM of 5 and 3 is 15. So you will multiply 3 in numerator here, and in the second term you will multiply 5 in the numerator to get 15 in the denominator. So this is 7 to the power 3 minus 5 over 15, or 7 to the power minus 2 by 15, which can also be written as 1 by 7 to the power 2 by 15. So generally we don't write powers in negative in the standard form. So we convert it into positive power by bringing it to the denominator by taking the reciprocal of that. Is this clear to everyone? Students, is it clear to everyone? Have you understood this? Arush, do you have any doubt? You have raised your hand.
Sir, I'm saying that, sir, previous Friday test series में test हुआ था.
No, there was no test because we already take these practice tests just after the class every day. So that's why we are not taking that Friday test. We'll have these tests after every class. We are doing that test, and that's why we are not taking the test. Okay. So if you have done this, can you tell me what formula are we going to use for the fourth question? 13 raised to the power 1 by 5 into 17 raised to the power 1 by 5. Here the bases are different and the powers are same. Which formula do we use here? So if you have written this, can I rub this? In the fourth question, which formula are we going to use? Can someone tell me?
Sir, we are using that a into b, a into a to the power m into b to the power m.
So a to the power m into b to the power m is ab raised to the power m. We take power common because the bases are different but the power is same. So we take power common outside the bracket and we multiply the bases together. This is what this identity says, right? So in this 13 raised to the power 1 by 5 into 17 raised to the power 1 by 5. Here the powers are same, 1 by 5. The bases are different. So what we'll do, we'll multiply these bases together, 13 into 17, and take 1 by 5 as the common power. So this is 13 into 17. If you calculate this, this is 221 raised to the power 1 by 5. Is it clear?
Yes, sir.
Students, please note this down. Shall we move to the next now? Have you all noted this down and understood this? Okay. Let's go to the next now. So these are simple questions. So one by one, you need to tell me how to solve this. So first you have to tell me what is the approach which you will use or apply to solve this question 64 raised to the power 1 by 2. Yes, Anay, can you tell me?
Sir, we will take 8 square and we will multiply it to 1 by 2 power.
Yeah, you can do that. Here we can easily see that 64 is 8 square, and that's why we are
Sir,
doing
or
that.
we take the 2. Let's we can take the 2 as a base and the powers.
Yes, I was coming to that. So generally what we do, Anay, is that, we always prime factorize this. It will, because here you can see 8 square, so it is easy. But generally, the general approach of solving these questions is to go with the prime factorization of the base. So here if we solve this first one, 64 raised to the power 1 by 2 can be written as, now this 64 is 2 to the power 6 raised to the power 1 by 2, right? 64, if you find the prime factorization of this, you will get, so if you divide by 2, 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2 and 2 and 1. So which is 64 will be 2 to the power 6. So we are using this. Now this is what? Power of power. So you will multiply the powers. 2 to the power 6 into 1 by 2. This gets cancelled. So this is 2 to the power 3, which is equal to 8. So this would be an ideal way of doing it. You can also do the way you have said, 8 square raised to the power 1 by 2. So here you can write 8 raised to the power 2 into 1 by 2. And that is 8 raised to the power 1, which is equal to 8. So answer will remain the same. But here it is easy. We know 8 square is 64. But if it is a bigger number or some other complicated number, then doing this will not be possible. Is it clear? Now, quickly,
Yes.
can you tell me what is 32 raised to the power 1 by 5? The second part. What is the answer for this 32 raised to the power 1 by 5? Yes, Subhranshu, correct. Yeah, Ane?
Sir, 2 to the power 5.
Yes, so we will write 32 as 2 to the power 5 raised to the power 1 by 5. 2 to the power 5 into 1 by 5 gets cancelled. So this is 2 to the power 1 and answer is 2. Right? Third one. Can you attempt this third one and tell me how to solve this? Yes, Subhranshu, it
Sir,
is correct.
5 to the power 3.
Yes, Ane. So this is 125 can be written as 5 cube. 5 into 5 into 5 is 125 raised to the power 1 by 3. So 5 to the power 3 into 1 by 3, this gets cancelled. So this is 5 to the power 1, which is 5. Yes, Aditi, you are also correct. Subhranshu, you are also correct. Okay. Clear? Shall we move ahead? Okay. So I hope everyone has noted this down. Let's go to the next now. So here you can see the powers are in fractions. So these are rational numbers as power, right? So first one, if you see, this is 9 raised to the power 3 by 2. So I can write 9 as prime. So as prime factorization, I can write it as 3 square raised to the power 3 by 2, which is 3 to the power 2 into 3 by 2, power of power. So we are using this a to the power m raised to the power n is a to the power m into n, right? So this is going to be, this 2 and 2 gets cancelled. 3 to the power 3, which is 27. Is it clear? Has everyone understood this concept?
Yes, sir.
Okay. Can you solve this second one now? 32 raised to the power 2 by 5.
Yes, sir.
Yeah, please solve it and tell me the answer. Yes, Subhranshu, correct.
Sir, we can take 2 to the power 5 into 2 upon 5, that 5 will cancel, and so the answer will be 2 square. So that will be 4.
Yes, correct. So in the second question, we write 32 raised to the power 2 by 5. So we write 32 as 2 to the power 5 raised to the power 2 by 5, which is 2 to the power 5 into 2 by 5, right? So we are using, since a to the power m raised to the power n is a to the power m into n. So 5 and 5 gets cancelled. This is 2 square, which is equal to 4. Okay. Now the third one, students, please attempt this third one.
Sir, can I tell the answer?
Sir, 2 power 4.
8. Answer will
2
be 8.
power 4.
2 to the power 4 is not the correct answer. 2 to the power 3 is the correct answer. That is 8.
Sorry, sir. 2 to the power 3.
Yeah. So 2 to the power 3 will be the answer here. So what we do here, we use the same identity. So in this question, third question, 16 raised to the power 3 by 4. This is 2 to the power 4 raised to the power 3 by 4, which is 2 to the power 4 into 3 by 4. So that is 2 cube, which is equal to 8. Okay. Now fourth one. Please attempt this fourth one. Now those who have not answered, I would like them to answer. Okay. So people who have been quite, Arush, just wait, let others also try. Yes, Subhranshu, it is correct. Anyone who wants to answer? Saktivel, Arsh, Aditi. Yes, Aditi, it is correct. Anna? Okay. Correct, Samagna. So in this question again, students, if you see this fourth part, 125 raised to the power minus 1 by 3. This can be written as so, because there is a negative power. What we'll do to make it positive, we'll take the reciprocal of the base, right? So 1 by 125 raised to the power 1 by 3. So this is 1 by 5 cube raised to the power 1 by 3. So this is 1 by 5, 3 into 1 by 3, which gets cancelled, that is 1 by 5. Is it clear? Is it clear to everyone? Have you understood? Everyone in the class, have you understood this? Okay.
Yes, sir.
Now in these questions, students, you have to again, use the identities. So you have to simplify 2 raised to the power 2 by 3 into 2 raised to the power 1 by 5, the first one. So here you can see the bases are same and then you are multiplying these numbers with different exponents. So in that case, we add the exponents. So the identity which we are going to use here is 2 to the power 2 by 3 into 2 to the power 1 by 5. So the identity which we are going to use is a to the power m into a to the power n is a to the power m plus n. Right? Can you solve and let me know the answer? Students, can you tell me the answer for this question? So here, because the base is same, we
The
add the
answer will be
powers.
2 to the power 13 upon 50.
Yes. So 2 to the power 2 by 3 plus 1 by 5, we'll add the powers. So this is 2 to the power, we take LCM as 15. And then 5 times 2 is 10. And here 3 times 1 will be 3. So this is 2 to the power 13 over 15. This is the answer. Is it clear? Saktivel, Arsh, Aditi, Saranya, is it clear to everyone? Okay. Can you do this second question? 1 by 3 raised to the power 3 raised to the power 7. What we'll do, which identity are we going to use here?
Sir, x to the power m bracket के बाहर n.
So then what do we write it as? X to the power m and bracket ke bahar n. What do we write it as finally? This is equal to x to the power m into n.
Yes, sir.
Right? So in this second question, we have 1 by 3 to the power 3 raised to the power 7. This can be written as 1 by 3, right? Raised to the power 3 into 7. So this is 1 by 3 raised to the power 21. Because 1 to the power 21 is 1 only, so that's why we leave it at as 1 and then we go to the denominator. Is it clear? So now third one, which identity are we going to use in this third question?
So we will use identity of a upon b, and the power of the a upon b will be subtracted.
Yeah, because we are dividing these exponents with same base, so we'll subtract the powers. So 11 raised to the power 1 by 2 divided by 11 raised to the power 1 by 4 will be 11 raised to the power 1 by 2 minus 1 by 4.
Answer will be 11 to the power 1 upon 4.
Yes. So a to the power m divided by a to the power n is a to the power m minus n. So here we are using this particular formula. So 11 raised to the power, we take LCM as 4. So we have 2 minus 1, which is equal to 11 raised to the power 1 by 4. Clear, students? Fourth one, students. Which identity are we using in the fourth part? 7 raised to the power 1 by 2 into 8 raised to the power 1 by 2. What is common here? The power
Sir,
is common here. Yeah. Go ahead, please.
Sir, the power is common 1/2 and the base are different, so the base will multiply.
Base will get multiplied. So fourth
Class
part
will be-
is 7 to the power 1 by 2, 8 to the power 1 by 2. This will be equal to 7 into 8 raised to the power 1 by 2. Using this, a to the power m into b to the power m is equal to a into b raised to the power m. So we are using this formula. So this is 7 times 8 is 56 raised to the power 1 by 2. Clear? Okay. Now let's move to a different type of question where you have to equate the exponents on LHS and RHS when the bases are same. If I write a to the power m is equal to a to the power n, what does this imply? This will imply, because the bases are same, the power has to be same, m is equal to n. Is it clear? If a to the power m is equal to a to the power n, since the bases are same, the power will also have to be same, and that's why we are equating the power m equal to n. So in the next question, next part, we'll use this particular concept. So you have to find the value of x if 5 to the power x minus 3 into 3 to the power 2x minus 8 is 225. You have to solve it for x. How do you approach this question? How do you do these kind of questions? Can someone tell me the concept here? What will you do first?
Sir, firstly, we will plus. Sir, firstly, we will solve the 225 in the simplest form in the exponents.
Yeah, so we will convert 225 as prime factors and then in exponents of prime factors, right?
Yes, sir. It will be 15 square.
Okay. So 15 square means 3 square into 5 square, right?
Yes, sir.
So then what you'll do after that?
Sir, we will if the base are equal, we will match them, and the power will be also equal.
So we will compare the powers of the bases. So if 3
Yes,
to the
sir.
power 3 to the power 2 will be compared with 3 to the power 2x minus 8, and 5 to the power 2 will be compared with 5 to the power x minus 3. So I'll tell you how to do this. So here this can be written as 5 raised to the power x minus 3 into 3 raised to the power 2x minus 8. 225 also needs to be converted as powers of 3 and 5. So if you do a prime factorization of 225, we'll start with the smallest prime number. So it's not divisible by 2, we'll divide it by 3. So this is 75. Again by 3 you will get 25. This is divisible by 5, and then by 5 we'll get 1. So this can be written as 3 square into 5 square. Now equate the powers of 5 and equate the power of 3 on both the sides. So by equating the powers, you will get x minus 3 is equal to 2. And by equating the power of 3, you will get 2x minus 8 is equal to 2. When you solve this, x will give you 5 here. And here you have 2x is 2 plus 8. 2x is 10. or x is 10 by 2, which is equal to 5. So in both the cases, you are getting x as 5 only. So the value of x which satisfies this equation is x is equal to 5. Is this clear to everyone? How we solve these
Yes, sir.
questions? So what we'll do, students, we will first factorize the number which is there on the right hand side, and then we'll write it as powers of 3 and 5. And because we have in the LHS powers of 3 and 5, we will equate the powers of 3 in LHS with the power of 3 in RHS. Again, we will equate the power of 5 in the LHS to power of 5 in the RHS. And after that, solving that equation on x, we'll get the value of x, which satisfies this equation. Clear, students? Shall we move to the next one now? Yes, I'll explain again, Anne. So what we have done here, see, we have this equation 5 raised to the power x minus 3. We had this equation 5 raised to the power x minus 3 into 3 raised to the power 2x minus 8. This is equal to 225. Right? Now here the power is in a variable. We don't know the power. Right? So first step would be to convert 225 as powers of 5 and 3. So if we do that, we'll find 225 is 5 raised to the power 2 into 3 raised to the power 2. Now what we'll do, we'll compare the powers of 5 and compare the powers of 3. So power of 5, if you compare x minus 3, will equate it to 2 because it has to be same. Similarly, power of 3 on the LHS and RHS needs to be same. So 2x minus 8, you will equate it with 2. And when you solve this, you will get the value of x which satisfies this equation. And you will find that that value of x is 5. So 5 is the answer here. Anna, is it clear to you? Anyone else? Is there any doubt in this question? If you have a doubt, I can, again explain it in a different way. And if everyone has understood, we can move ahead. Neha, Anay, Arush, you have understood everything? Subhranshu, Samagna,
Yes, sir.
Saranya, Aditi, Ars and Saktivel, Hana. All of you have understood everything? Okay.